All right, so here we're going to talk about non-parametric analysis, what these tests are and why we might use them. Essentially, non-parametric analyses are a small family of models that make fewer assumptions than linear models, or in other words, their parametric counterparts. Now, when looking at the difference between parametric and non-parametric tests, the differences lie within the basic assumptions. So if we look at basic assumptions of a parametric test, we have normal distribution of the outcome variable, a sample size greater than 30. The dependent variable is a continuous level of measurement, or it is interval or ratio. And we assume homogeneity of variance within the dependent variable. On the other hand, our non-parametrics, normality is not assumed. We do not require a large sample size. The dependent variable can be a nominal or ordinal level of measurement. Interval is not required. And then assumption of homogeneity of variance is not required. So when do we use these non-parametric tests? When our data fails to meet some or all requirements of parametric statistics. However, when in doubt, you should typically lean towards parametric. We need the violations of these assumptions of parametric tests to be severe. For example, we have a non-normal distribution and very small unequal group sizes. For example, in an exercise physiology study, you may have a very small sample size made up of both trained and untrained subjects receiving the same intervention. And we know that can create some non-normality within the sample. Because non-parametrics have fewer assumptions, in some cases, they may have less statistical power than their parametric counterpart, but this is typically only when the sample is normally distributed. So this is not always true. Some examples of non-parametric analyses are the chi-square test of association, and that can be one-way or two-way, Wilcoxon by rank, Friedman one-way ANOVA by rank, Mann-Whitney-U, and the Kruskal-Wallis test. Non-parametric methods will typically involve rank, frequency, or finding medians. And this is because the dependent variable is nominal or ordinal. So an example research question might be, do male or female athletic trainers report more satisfaction with their work-life balance? With the independent variable here being gender, male or female, dependent variable being satisfaction, and put into three categories, three choices of satisfied, neither satisfied nor dissatisfied, and dissatisfied with their work-life balance. So let's look at our basic assumptions. Right away, my dependent variable is a nominal level of measurement. Therefore, automatically, I'm going to need to use a non-parametric analysis. And then I'm looking at the difference in frequency in response. So how many athletic trainers report that they are satisfied, how many report that they are neither satisfied nor dissatisfied, and how many are dissatisfied. So I'm looking at those frequencies. I'm also looking at the relationship of frequencies between my two independent variables. So are gender and work-life balance somehow related in the athletic training profession?